everyone. Thank you for having me. It's such an honor to follow these great speakers before me. So thank you so much. The clicker. What I want to talk to you about today is agents in the enterprise. So we've been running agents in the enterprise for about a year. So we've been running it internally as well as externally. So we ship these agents to customers as well as a part of our offering. And so, what I want to talk about today are lessons we've learned, best practices, and other things that we've come across as we've sort of been running these agents at scale. So to start with, it's best to sort of define what an agent is, because I've heard, I think, millions of different definitions of agents, and it's overwhelming sometimes. But agents are essentially just LLMs running inference in a loop. So what you do is you take an LLM and you give it prompt, and you give it a bunch of tools to execute. And then what the LLM does is that it decides which tool to execute, and then we just execute the tool, do the action, and then that runs in a loop. Right? So what that actually looks like is something like this. So the first thing you do is you provide what is context or perception to the LLM. The first stage is you gather context. So in our case, because we create coding agents, the first step is to actually gather code files. So we figure out what code files to modify, where the code could possibly live. We create like a graph of the code, and we fetch the relevant sort of functions or tests or whatever else that needs to be done. But this could be different for if you're not in the coding world. This could be documents that you have, like your specs in like a document store, in SharePoint or in Confluence or whatever else. Or this could be a knowledge base that you have in a vector store. And then, of course, you've got memory as well. This is like your past interactions with the agent. That's stored as well, and that's context to the next run for the agent. The next thing is the actual reasoning phase. So the agent goes through the process of actually creating a plan, deciding what needs to be done, and then executing on the plan, deciding which tools are best for it to use for that particular phase of execution. And then it actually decides to go ahead and actually run those actions. So these actions could be anything from creating a ticket in Jira or doing a Google search or something like that, right? So these are different actions that will execute. And then the final step is the actual feedback loop. So the feedback loop consists of actually looking at what it's done, the result of those actions, and deciding what to do next, right? At this stage, you could do things like compaction, reducing your context size so that you can do the next, because all of these LLMs have context limits, right? And so there are various stages that you need to do through the feedback loop as well. All right, so I'm going to show you a coding agent and show you these different phases that you actually go through. So this is a simple sort of Java upgrade agent. So I'm asking it to upgrade this very simple project from Java 8 to Java 21. And so I give it a goal, right? So the first thing, what we spoke about is perception or context building. So if you see, it's going through all your code files and it's going through this graph of code that we developed, and it's trying to figure out what it needs to modify, right? So with that, it sort of grabs understanding of a current repository, and then it develops questions for you. So basically what you'll see soon is that it'll go into this phase where it will ask you questions around, all right, this is the upgrade plan, what do you plan to do, right? And so it asks you some specific questions. In this case, I've just dismissed it, saying, just go ahead and upgrade everything. And so use as many features of Java 21 as possible and go ahead and upgrade, right? And showcase best practices as well, just because it makes for a good demo. And so then it's gone ahead, and this is the next phase now. There's the thinking phase where it's got thought through and come up with an actual plan, right? And this is the important part of it. It's important to have human in the loop as soon as plan is created, right? So you want, once a plan is created, to get the human to approve the plan, to decide so do I need to upgrade all files or not? And so once the plan is actually approved, it goes into the phase of actually execution, which it starts executing tools. In our case, it can read files, it can edit files, it can create files, it can look at directories, it can look at knowledge base, etc. And so that's what it's doing. It's also running things like Gradle commands to actually build and make sure that the project actually builds after it makes the changes. And that's the whole feedback loop. So that's essentially what we spoke about in the previous. All of those steps were executed by this agent here. All right, so that's basically an introduction to what agents are. right? So agents are these things that run in a loop and run tools to actually make changes to your environment. But as we've sort of been doing this, we've realized that lots of security considerations. The first thing is that because we allow agents to actually execute actions, we need to securely put it in a sandbox, especially for this is true for coding agents, but it's true for all other agents as well. For example, an Excel agent needs to also run code. It needs to run code in a secure sandbox because it's going to be able to load an Excel file into a pandas data frame and then execute on some commands, right? And so sandbox execution is a must. And so the way we do this is we run this in our already existing sort of very vast CI infrastructure, which is it's hardened over time. We've got guardrails around it. We've got network policies to prevent that. But that's what you essentially need to do to run these agents at scale. You need to create a sandbox either in Kubernetes or in containers or VMs or micro VMs or whatever to be able to actually isolate these agents to be able to do exactly what you want them to do. So that's the first one. I've got a demo later showing you how that works in our case, but that this is relevant irrespective of whether you're executing it with us or somebody else. The next bit is about permissioning and least privilege, and this is especially important as you give LLMs access to data. So as you give LLMs the ability to create SQL queries or create graph queries or whatever else, you want to make sure that you're giving them least privilege. You don't want to give it access to drop tables or delete records unless you specifically want that. And so it's essential that as you're creating these tools, you constrain these tools and the users that these tools use so that you give it the least access possible. And this may seem obvious, but it's not many times. Many times agents are very, very creative to figure out how to modify things. And so if they run into a roadblock, they'll figure out 3 ways or 4 ways to figure out how to get out of it. So for example, if you say this tool can't edit this file, if you put in the prompt, it'll still do it. It'll ignore the instructions and still try to edit a file. Or even if you put constraints saying, oh, don't edit this file, it'll try to run a command to edit the file. So it'll do echo into the file and try to edit the file. So it will find many ways to go against your guardrails. And so you want to make sure that you do least privilege in every way possible and prevent it. So we do this with file system sandboxing, and we run bubble wrap in Linux containers to be able to do this. But there are many ways to sort of achieve that isolation. In addition, just about tool calls, you don't want to let LLMs create raw SQL queries, or in our case, raw Cypher queries, because what happens is that as they create these queries, you want to constrain the sort of join operations that they can do, and you want to make sure that they are adhering to your entitlement requirements, your security requirements. And so we never let our LLMs do raw SQL queries. Instead, we create a JSON format which severely limits the sort of selections that it can do. The next bit is around logging and audit trails. Now, this is a mistake we definitely made from day 0. We do not have enough logs and audits for our agents. And so we definitely thought of this on day 2, once we started running into issues in production. But this is, what I would recommend for everybody is, log everything that the agent does. Everything from every tool call that's made, from actions and outcomes that the agent's making, you need to log them to be able to have some sort of trail when a production incident happens. And then, of course, red teaming is super important. So we have a whole set of hackers which are trying to figure out how to break our own systems. And I recommend that to everybody because there are so many vulnerabilities, and the environment for vulnerabilities is constantly changing. You won't believe how many types of different prompt injection attacks are available today, from writing, because LLMs become smarter over years. They can understand base64 text. They can understand Morse code. They can understand anything that you put that you would think is harmless in a PDF. And so there's a need to be constantly red teaming your agents and figuring out what are the issues. All right, so this is an example of running an LLM in a sandbox. So in this case, we are running Cloud Code. And this is in GitLab, we ask Cloud Code to create an implementation plan for this user story. And so if you see, we're running this in a secure Docker container, running in a VM. So we run a VM first, and then we run a Docker container in the VM, and then execute the LLM in that Docker container. So we're executing the agent, not the LLM, in a Docker container here. And so as you see, as it starts executing, and it's quite quick at that, it's constrained. It can't do things like it can't make changes to the environment. It can't touch files outside of the repository that it's trying to modify, etc. Okay. The next bit is auditing and human in the loop. Some parts of the slide are missing. But anyway, so basically, human in the loop is very important. There's a need for final human intervention, right? So we had this whole process of getting humans to approve every tool. So we started off in that way, where we said, hey, every time a tool runs, you approve it manually. But what we noticed in our testing was most people just approve the tools anyway. 95% of the time, they just click approve because 95% of the time, the LLM is right? But the 5% it's not is the dangerous part. And so we are very selective in how we let people auto-approve tools. We only let them auto-approve tools if the tool isn't doing a right action. So if the tool is doing a read action, that's fine. If it's doing a right action, we prevent that. But we also make sure that every MR that is created, either internally or externally, is reviewed by somebody. So every merge request, every change that's made to code has to be reviewed by two sets of human reviewers before it's actually committed to production. And that's necessary because the LLM will miss things, or the first set of human reviews will miss things. And so it's important to do that. The second thing is continuous monitoring. So what you want to do is you want to always monitor the actions and have a constant stream of monitoring the actions that the LLM is performing. These actions could be writing a ticket in Workday or creating a ServiceNow incident or whatever else. You want to monitor and you want to track all those actions. And you want to see, are there any anomalies in these actions, right? And so you can do that by using a simple sort of regression model to figure out what actions are typically performed in the course of a task and what actions this LLM has performed. And that's the only way you can actually do tracking for what sort of security issues could occur. The other thing is what we propose is always using workflows instead of pure agents. So workflows are where you place agents, but you also have a set of deterministic steps and human check steps. So you combine agents and deterministic steps together. And that's really important. So you can have controls and guardrails on what are the things that you can execute. So for example, at the end of, let's say, we have a security agent which allows you to accept or dismiss vulnerabilities. So we make sure that there's always human check before a vulnerability is disabled, removed. And so that's really important for us to make sure that you have those steps in place. So workflows are super useful because you have determinism in the whole flow for these LLMs. Okay. So the next bit is around connecting your enterprise and connecting your LLMs to actual enterprise data. And this is a must for most enterprises, is the ability to connect your enterprise to enterprise data, whether it be in Salesforce, in Workday, in AWS or whatever else, to these LLMs. The LLMs have a better understanding of what your landscape looks like. And there's a standard for this, that's MCP, which stands for Model Context Protocol. But at its core, it's just a very simple sort of JSON RPC-based API that lets you connect an API to a model, right? And connecting APIs to models are extremely, extremely dangerous because now it has access to external data. It can make more mistakes. And there are tons of prompt injection attacks that can occur from this. So one of the first red team incidents we had was where our internal team was able to insert invisible text into our issues into public issues. And so as soon as the LLM would read, so you would tell the LLM, hey, this is a user story, could you implement this? And as soon as it read that, it got injected. So it was like, oh, exfiltrate this information in invisible text that no one could read, right? Because you can have invisible text and instructions in Markdown. And so as a result of that, the LLM would then go exfiltrate that information. And that's dangerous. And so the moment you give API access to your LLMs, it opens up a whole set of vulnerabilities and exploits that can happen. And as a result, you do need to sanitize the data. And these are data sanitization things that we've been doing for ages, but it's even more important in the LLM world because the LLM is the model in the end is naive. The model in the end will follow instructions, and you've been trained in a way to please. And so what you want to do is you want to be able to make sure that the data that the LLM is getting from external systems, specifically public data, is really important. Internal data is also important, but not as important as public information. That you make sure that it's not that there's no injections in there. And prompt injection is a type of attack where you would put in something that may be imperceivable to the user, but then would direct the LLM to do something else. So MCP is a great way to actually connect your LLMs to data, but it can be dangerous as well. So the way we recommend you use MCP is you create a good set of standard MCP servers in your enterprise. And you should use the remote protocol and not the sort of standard I/O protocol for MCP, because the standard I/O protocol involves you like installing an NPM package or a pip package on your machine, and you have no control over your enterprise when they start doing this, right? You lose control over which versions have, who's installed which version of the MCP server. And so as a result, the best way to do this is to have a good standard set of MCP servers that are fronted by an enterprise security layer, something with authentication, with entitlements and everything else, so you can apply those guardrails to this. And so our recommendation is always to go with remote. All right, so this is an example of MCP. So I'm using the Claude app in this case, but I'm pointing to the GitLab official sort of remote MCP server. And so all you do is you tell Claude that I want to use the MCP server. And now I can actually just take a GitLab issue and paste it in Claude and say, hey, can you explain what this issue is all about? And because of the MCP server and it's connected to GitLab, and you can see the list of tools it gets as a result of just connecting that one URL, it can now go and actually view the contents of the issue. So, of course, Claude isn't trained in that specific issue, but it can then use that tool to actually go and find what's in that issue, and it can go and summarize the issue for me. So it can execute tools. So that's a remote MCP server that allows you to do this. Okay, so the next bit around scaling agents in the enterprise. So what we have is the need for an agent control plane. So as you get many of these different enterprise agents, so you may have several thousands of these running in your enterprise, what you want to do is have some sort of observability. So you want to monitor and audit the actions that these enterprises are doing, these agents are doing. It could be from executing tools to actually figuring out how much these agents cost. And so all of that has to be monitored and put into your agent control plane. So what the agent control plane is, so when an agent comes online, you want to typically register it with your control plane. And then as you can monitor these agents across your enterprise in one single place, and that's really important. You can then apply governance to these as well. So you can have governance policies. So you can have policies which define which projects are allowed to run these agents and which are not, because you have some projects which may be dealing with MNPI information or PII information, and you don't want those to run these agents by default. And so you can then execute governance at a centralized point. Another thing is around multi-tenant. So we run a multi-tenant environment, and that's why it's really important for us to see which agents are executing and how they're executing, because we get noisy neighbors all the time. The agents can run for hours and finish off tokens and hit our limits as well. And because we use upstream models, we use Anthropic and OpenAI, and so and Vertex, and so we would run into several token issues if we just let these agents run endlessly. And then finally, cost management is really important as well. You want to be able to track costs at an agent level. You want to be able to track and understand what the costs are first, but then also there are many ways to optimize costs as you sort of get into this. There's caching that you can do at several levels to figure out how you can reduce your context for each call, and then also reduce the limits that you have as well. So that's it. That's my talk on agents in the enterprise.